allow me to introduce our keynote today, David Browning of Enveritas.
Great. Well, thanks so much, Joe, and good afternoon, everyone. It's a pleasure to speak with you today. I'd like to thank WCA for hosting this event. When we think of traceability and transparency, we tend to think of physical movement of coffee through the supply chain. But there are other transparency and traceability issues that need to be accounted for, such as deforestation detection. And today I'd like to share with you some important digital innovations that have been happening in this space. Deforestation has been important for coffee supply chain assurance for a long time, but there's a much greater sense of urgency today due to momentum around climate change. In 2005, the Kyoto Protocol came to being. This represented the first internationally legally binding climate treaty. In 2015, the Paris Agreement was signed, and since then, almost every nation, I think 197 countries, have endorsed the agreement to reduce emissions and reach global net zero by the second half of the century. And in a few days, the international community will come together again to discuss progress since the Paris Agreement and try to push towards more ambitious targets. And this momentum at the global diplomatic level has permeated the private sector, including the coffee industry. Nestle has committed to net zero by 2050, Lavazza by 2030, Blue Bottle by 2024, and Nespresso by 2022, which is only 2 months away. So this is great. We have vision, we have committed leadership, and we have concrete time-bound goals set down on paper. And we're eager to get from here to there. But an important question before we start is, where are we? It's hard to know where to set sail if you can't answer that question. And it's even harder to know if you're heading in the right direction. How much carbon is being emitted by a coffee company today? And if we take action, have carbon emissions been reduced? And how will we know when we get to zero? One of the important potential contributors to company carbon emissions is deforestation. Here is a satellite image from forest in 2017, and here is the same place in 2019. The forest is gone. Was this deforestation captured? Was every event like this all over the world captured? If you think about it, what is behind the deforestation numbers that appear in corporate reports? How are they measured and how accurate are they? Today, I'd like to explain what the traditional approach has been to calculate deforestation, including 6 limitations that historically existed. But I'd also like to share with you new digital tools that promise to give much greater transparency on this issue. And the reason I'm excited is it offers the hope to merge this unprecedented corporate interest in reducing carbon emissions with a better map of where we are and where we're going. So how do we measure deforestation? We primarily use satellite imagery, such as this one, combined with artificial intelligence to analyze the images and detect change. This is the MERIS satellite, which has done remarkable service for science, providing contributions in our understanding of clouds, water vapor, phytoplankton in oceans, and much more. However, there are a few problems with using MERIS to measure deforestation for the coffee industry. The first problem is it's not very granular. It was launched in 2002, nearly 20 years ago. This is an image of the Sydney Opera House using advanced recent satellite imagery at a resolution of 50 by 50 centimeter pixels. This is the Opera House with slightly lower resolution, 5 by 5 meter pixels. The same image at 30 meters. And this is the image with the MERIS satellite, 300 by 300 meter resolution. The Opera House disappears into Sydney Harbour at this resolution. If someone can steal the Sydney Opera House without us knowing, you can see that it probably isn't the best technology to be monitoring deforestation in coffee. And the second problem with using MERIS is that it's now lost in space. We lost contact 10 years ago, so we can't get any updates on the information it provides. So using it as the baseline has some potential challenges because we're not able to update it from the same source in the future. A third problem is that historically we've had to do a lot of extrapolation from satellite data. This is the JEDI satellite track, which is often used for deforestation calculations. It only covers 4% of the land surface, which are the green lines that you can see in this image. And then it has to deduce what the rest of the picture is that it can't see. A fourth problem is the world got very ambitious when we first started talking on this topic about what would be measured, dividing forest up into 4 different categories and then dividing non-forest up into an additional 2 categories, or 6 categories in total. So the ambitious approach traditionally taken was to use a few data sources, in this example, the 2 satellites, JEDI and Sentinel-2, and then use that information to predict many variables. So here's an example. I'd like you to focus on the forest around the yellow dot and try to classify it. Is it high density forest? Maybe medium density? Maybe low density? Well, the correct answer is it's not forest at all. It's scrub. And if we make the error of classifying it as high density forest rather than scrub, and it gets cut down, then we've overestimated the deforestation by a factor of 5. Now you might say, okay, but how do you know it's scrub? Maybe your new AI model is wrong too. That's a great question, and we'll come back to that a little later. A fifth challenge is that we haven't been taking advantage of the significant improvements that occurred in artificial intelligence around 2016. A technological step change occurred around that time that provides much better ability to detect and identify different crops as opposed to just seeing them as trees. But this isn't incorporated into most deforestation models. This the image you're seeing is a commercial palm oil plantation in 2018. This picture is taken in 2019. The plantation has been cut down and replanted. This is not deforestation, this is commercial agriculture. If you look closely in the image, you'd be able to see the new palm trees starting to grow already. But it was incorrectly classified by old AI models as deforestation, which is shown here in pink. So the question is this a big problem or is this a little problem? Does this sort of classification error happen a lot, or is it a rare occurrence? If it's a rare occurrence, then we really don't need to worry about it. But in Sumatra, at least where we've checked, it's a big problem. 75% of the total estimated deforestation in 2019 is probably in error, and primarily from rubber and palm plantations being overestimated. A sixth problem, and the final problem I'll discuss today, is we haven't been ground truthing. So let's go back to our spot in the forest with the yellow dot. It looks like forest from satellite image, but once you get on the ground, it is not. This is a photo north, south, east, and west, straight up on this yellow dot. The height, the tree height is less than 5 meters, the definition of forest. So while it looks like forest, it is in fact scrub by the definitions the world agrees upon. And this would be even more difficult to classify accurately if we're using low resolution imagery, as we discussed before. This is another example from the coffee industry. This is a place which was classified as forest was in fact coffee plantation interdispersed with pepper. So Enveritas took a different approach. Rather than try to divide into different forests, we've attempted to answer less questions more accurately. Is it forest or not forest? And using a variety of different data sources, including ground truthing. We've taken advantage of more recent satellite imagery that can provide far greater coverage of the Earth's surface than was traditionally possible. And while traditional AI models can easily detect crops such as palm or maize, which are easily distinguishable, determining forest from what is not forest in commercial crops has been far more challenging. But we built more accurate AI models that can do this and provide far greater supply chain transparency. To get a sense of what a significant step this represents, have a look at these images and attempt to classify which ones are forest, which ones are rubber, and which are commercial cocoa. And you can see the challenge. These are the actual answers. And this dramatically improved predictive model is also able to identify real deforestation is occurring. This is deforestation occurring on the edge of a national park. And this is coffee that's being planted amongst the burnt remains. So to give you a sense of how this can have real world application, this is Bukit Barisan, a national park in Indonesia. It's home to about 40 or 50 Sumatran tigers, which are a critically endangered subspecies. Every year, forest inside the park is cut down, and in some places, it's being replaced by coffee. But where and how often? Here's a map of Sumatra. The national park Bukit Barisan is located in the south of Sumatra. And the national park boundaries and the interior of the park are shown here in green. And here you can see the specific deforestation events that are occurring up in the north part of the park this year, specifically between January 1st and September 30th of this year. And if you'd like to ask the question, well, is it possible to get digital traceability in even more real time? This is an example of deforestation that happened just 2 weeks ago. And that deforestation is likely to be happening as we speak today. A lot of innovation has been happening in digital traceability in the past 3 years, and we're only just getting started. Thanks for your time. I hope you enjoyed the other speakers and the panelists. Back to you, Joseph.